The project that we are going to see here is the performance comparison of various compression techniques in ECG signal. The basic objective of our project is to reduce the unnecessary low and high frequency samples which occupies large space during storage. Hence, by the use of transform techniques such as DCT, DWT, FFT, we can prevent it. Now we can go into this project. The basic block diagram of our project is shown in the figure. It explains how the original signal is reconstructed. The original signal is sampled at its initial value and then given as an input to the transformation techniques such as FFT, DCT, DWT and DST. Those output are given to the quantizer as an input. This quantizer allows the signal to reduce to its minimum amplitude level. The output of a quantizer is given to the inverse transformation techniques such as IFFT, IDCT, IDWT and IDST, which is a compressed signal. The compressed signal which is given to the inverse transformation techniques allows to create a signal which is similar to that of an original signal, that is also called as reconstructed signals. We can compare the error by use of an error detector. The error detectors compares both original signal and the compressed signal, which allows how much of an error which is deleted during the compression process. The basic explanation on ECG is given here. A ECG is a test that detects and records the electrical activity of the heart. It is used to detect and locate the source of the heart problems that include angina, palpitation, dyspnea. An ECG shows how fast the heart is beating and how healthy the heart muscles and valves are. The technique that we are using for ECG signal compression are for two main reasons. They are effective and economic data storage and online transmission of the signal. As mentioned above in the block diagram, the technique that we are using for compression of ECG signals are the transform methods. The transform methods are DWT, FFT, DCT and DST, where wavelet transform has relatively better localization property both in time and frequency domain when compared to TFT. The clinically relevant parameters that are to be present also in the reconstructed signal are listed here. The parameters that are shown here are the important one in an ECG signal, hence reconstruction is necessary for these signals. The basic operation of our project is shown in the figure. In this project, we intend to implement a discrete cosine transform, fast Fourier transform, discrete wavelet transform based ECG signal compression. In this signal, first transform to frequency domain, a nonlinear transformation is applied on frequency coefficient, and then inverse transformation is computed to obtain the reconstructed ECG signal. The quality of a reconstructed signal is compared to that of the original signal subjectively by using plots and objectively by using mean square error criterion, compression ratio, etc. The analysis of our project. The recorded ECG signal of which is containing the low frequency and high frequency sample. The high frequency samples are having a negligible value which also occupying the time domain. So by neglecting these values or by making high frequency to 0, the removal of these values reduces the ECG signal. This leads to the compression of ECG signal. The implementation. Implementation, as explained in the block diagram, it is the steps that we are using in order to get an reconstructed signal. The basic formula for a compression ratio is given, and also the error is computed by using the signals obtained. At last, the applications which we are using are digital Holter recording, ECG signal archiving, ECG data transmission through communication channel, and telemedicine.